afternoon, everyone. First of all, thank you so much for your time, and I hope you are all safe and healthy, even this time of COVID-19. So before we officially begin, yeah, thank you so much for applying for this particular online masterclass on natural language processing. I'm so excited to show you what's in store for us this afternoon. We invited a very special guest speaker to discuss about NLP, its fundamental and use cases. But before we begin, allow me to quickly introduce myself. I'm Roy Joseph Roberto. I'm the current president of the AAM Society of Innovators, and currently I'm pursuing my master's degree in data science at the Asian Institute of Management. So maybe just to give you a little bit of background about the AAM Society of Innovators, it's an officially recognized student organization at the Asian Institute of Management. It's an international research and management school co-founded by prominent business leaders in the Philippines, some academic institutions, and the Harvard School of Business. And our aim is to empower our members and the community by providing learning and growth opportunities on 21st century skills. So with respect or in relation to this organizational objective, we have launched what we so call as Innovation Cafe. It's a series of digital seminars on 21st century skills. When we say 21st century skills, we're talking about data science, artificial intelligence, big data, systems and design thinking, entrepreneurship, and other important skills such as business, technology, and innovation. So we are organizing different kinds of digital seminars on different kinds of topics, and then we're inviting speakers from different parts of the region to share their knowledge and expertise on these subject matters. So if you are interested for more opportunities, follow us on Facebook, AAM Society of Innovators, or if you are interested to be part of our speakers network, feel free to get in touch with us as well. So without further ado, allow me to introduce our very special guest speaker for this afternoon. Hang on. Okay, so for this session, we will discuss how the so-called smart machines or AI system are able to understand the complexities of the human language. Our speaker, Jude Michael Teves from the Philippines, will talk about the fundamentals of NLP, as well as share his experience working on the implementation and management of different related projects as part of ADB's innovation team. Jude is currently an artificial intelligence and machine learning engineer at the Asian Development Bank, or ADB, and just in 2019, last year, he earned his master's degree in data science at the Asian Institute of Management, where he graduated as Batch Salutatorian. And he also graduated with high distinction, the highest academic award given by the institution. His current work in ADB includes the implementation and managing of a variety of projects in the fields of computer vision, natural language processing, data analytics, and then the Internet of Things. He also served as the lead data scientist for an NLP deep learning project, specifically the lesson extraction model for the project completion reports of the independent evaluation department in ADB. He is also the project manager for a chatbot project for procurement, portfolio, and financial management department in the bank. As part of his work as a consultant, some of the services he provides include the development of end-to-end machine learning and AI applications, geospatial analysis, as well as the creation of portfolio models for the electricity markets. He has also won several hackathons in AI and is currently one of the ambassadors of Make Sense. It's an organization promoting technology and social innovation. So without further ado, oh, by the way, just some house rules, no? If you have questions for the resource speaker, please type in your questions in our chat group, because later we will consolidate. There are so many attendees and we cannot accommodate every one of you. So please type in all your questions in the group chat, and then we will consolidate, and then the speakers will perhaps pick and choose some of the questions that might be relevant for our target audience this afternoon. So without further ado, Jude, you have the floor. So Jude, you may now share your PowerPoint slides, and maybe you can say hello to our attendees this afternoon.
Sorry for that. Technical issues. Sorry, just opening the slides.
Sure, take your time.
Wait, let me share my slides. All right. Can you see it now? Good. Okay, so hello everyone. Once again, I am Jude, and as Roy had mentioned, I currently work as an AI ML consultant in the Asian Development Bank, where I have multiple roles. I work as a data scientist, I'm also a machine learning engineer, and a project manager. As part of the innovation team there. So basically, what we do is there's a client, an internal department, and then we provide services to them. So we propose an innovative solution, and then we implement these things. So that's what I do there. And I also work as a independent consultant for different institutions or organizations. I provide data science and software engineering services. So I work on computer vision projects, customer segmentation, portfolio monitoring, so on and so forth. Previously, I also worked as a software engineer in Navigator, where I create mobile applications for airline companies. And I took MS in Data Science in AIM, and I also took Bachelor of Science in Computer Systems Engineering in the De La Salle University, and currently ambassador for Sense. So, aside from my career, I am also fond of joining competitions. So, just recently, last year, we were the grand champions for the Google ML Hackfest. And I also became finalist for many other hackathons like ADVA Hackathon, the Accenture, Within the Future competition, Crucible, and I'm also fond of doing sports. So with my friends, I do volleyball, I do obstacle course racing, I do lots of sports basically. And I also do speaking engagements like this one. So last year we had a talk in a province when we evangelized data science, AI, and industrial revolution to government officials. So yeah, throughout my career, I have been engaged with lots of companies, mostly tech. So I'm currently working in the Asian Development Bank, but I've also worked in, I have also collaborated with companies relating to airline companies, and also I'm also linked with USC because I was a AI scholar back then. So that's just my background. Anyway, so without further ado, I want to ask you a question. Who among you guys have an experience with NLP? Who have created NLP projects? We'll be having a poll right now. Roy, can you ask the poll? And Roy will be sharing the results. Anyway, I can see it. I can see the results. So,
Yes, Jude. So very interesting results. 70% of our attendees for this afternoon do not have an idea about NLP. So I think it would really help them if you can discuss the fundamentals of NLP as well as its high-level applications, about the different projects that you did in the Asian Development Plan.
Okay, that's good because that's just right because the purpose of this talk is to explain the fundamentals of NLP to the people, to the general public. Okay, so start. Um, so I think the best way to explain first is by showing examples. So one example of doing NLP is through theme identification. What you can see on the right side is actually your responses. So these are your backgrounds. From what I can see, most of you are students. Um, some are studying data science, analytics. Some are engineers, consultants, business people, software engineer, I guess. Um, so yeah, mostly technical background. Just right. Um, I'm sure you're gonna enjoy this because this is a very technical topic. Here's another one. So um, here's on the right side are the things that you want to be discussed in future sessions of the AIMSI webinar series. So most of you likely would like to see more about it, of course. There's computer vision, data science, reinforcement learning, analytics. There's about something about COVID, energy, so many things. So this is one thing that you could do through NLP to analyze these kinds of things, anything that is text related. One popular example is chatbots. So through chatbots, we can automate many things, many of the things that business would need. So for example, if you have been asked many repetitive questions, you could just create a chat system for that so that you wouldn't spend time answering all the queries that different clients would have to use. So the good thing with current chatbot systems now is that they're very easy to create, they're very easy to train, and then you could do so many things like that. It could do your bookings, it could you could do orders, or so many things. Another thing that you could do with NLP is sentiment analysis. So for example, you have a news and you would like to identify the general tone of that news. So for example, I have here a news about coronavirus. So the title is Coronavirus Survivors Donate Blood to Help COVID-19 Patients. This is from Rappler, and they have a feature where you could input your sentiment regarding that news. But what if it's not possible? Then we could use AI techniques in order to determine the sentiment of the news. So I would like to ask you guys, what do you think is the sentiment of this news? So, Roy, take the poll now. Okay. So, Roy, are they done responding?
Yes, Jude, our participants are still answering the poll, but
Okay.
maybe you could speak more clearly or
Okay,
louder,
okay,
a little
sure.
bit louder. Yeah, thank you.
Sure.
So
Positive,
interesting
oh.
results again, yeah. So
Positive
81%
like that, yeah.
said it's a positive sentiment. Only
Mhm.
4% said it's negative, and then 17% said it's neutral.
Okay, interesting. I actually had an AI model determine the sentiment of this news. So what the AI got is that most, sorry, it's generally a neutral topic. So maybe the AI model wasn't that good enough. But that's one thing that you could do with NLP. So you can automate these things. If you don't have the different users do the sentiment by themselves, you could do it by using an AI. So next, machine translation. This one very important example because I'm sure you have used Google Translate. So what you can see on the right side is basically Google Translate. So the first query that I have there is je ne sais pas. Je ne sais pas is basically I do not know. it's a French phrase, sentence. So it was the Google Translate was able to detect that it is a French language and converted it into English. And I also have another example here. Ang tubo ay masarap, which translates to the prophet is delicious. It is correct, but it could have different meanings. So tubo, for non-Filipinos out there, tubo means prophet. It could mean sugarcane, or it could mean pipe. So it depends actually on the context, which we didn't explicitly input it here. There's no context. So current AI models right now are also do also suffer from ambiguity. So they're not there's no perfect system. So if we're in a farm and I said ang tubo ay masarap, then it would make sense that the translation would be the sugar cane is delicious, but the AI model doesn't know that. So that's one limitation of AI. Another example is text generation. This is actually one of the cornerstone of modern artificial intelligence. I would say the holy grail of AI is by achieving good understanding of human language and being able to understand videos, images. So the two hardest subfields of AI are computer vision and natural language processing. And actually, natural language processing is much harder than computer vision. If you could see now, this is very technical, but there's this thing called the ImageNet moment of computer vision. It happened in 2012, but the ImageNet moment of natural language processing happened 2 years ago because of transformers. The transformer birthed those things. But yeah, this is state of the art. Text generation is state of the art, and I got this excerpt from the internet. So I will read this. General artificial intelligence is going to happen a few years from now. There is now a reasonable amount of skepticism about whether AI will be an improvement on us. At present, its ability to generalize new situations is questionable. The challenges of language processing and scientific modeling are significant, while ethical issues are formidable. However, it is clear that today's AI systems are progressing at an extremely fast pace and that their numerical capabilities are increasing. Actually, I agree with this statement, but we want to ask a question. Go, Ray. Would you like to ask the question regarding this?
Yeah, so do you think this text is written by an actual human? Well, a lot of our participants said they are not entirely sure.
Which makes sense.
And then it's like a tie for those people who said no, this is not written by a human, and then yes, this is obviously written by a person.
Well, that's okay. Okay, so actually this is AI generated. So I use the talk to transformers. You could access the link. It's available on the internet. But what it does is you provide an initial sentence or phrase, and then it continues that. So my initial sentence here was the first sentence. General artificial intelligence is going to happen a few years from now, and then the AI continued that sentence. So that's one example of state of the art NLP. But in order to get to this output, I actually had 3 trials because like all systems, there are some limitations. So for example, let's wait for the other example. 1 plus 1. The current state of the art models cannot understand concepts. So if you look at the output, it's just gibberish, right? So and also to get a good result, you have to do lots of trials. So yeah. All right. So with all that, what is natural language? So formally, in a broad sense, natural language is a language that is used for everyday communication by humans, languages like English, Hindi, or Portuguese. And I actually got this definition from this book, The Natural Language Processing with Python. I recommend reading this book if you're still starting with NLP. It's very practical and quite comprehensive, but it just covers the fundamentals, not the state-of-the-art ones. So what is natural language processing? I'll let you know what natural language is. It's just the manipulation of natural language using any means. It could be as simple as just counting the frequency of words in a sentence, or it could be as complex as making use of those state-of-the-art AI models to understand the context of your sentence. So in order to manipulate words, we have to understand first how computers see words. So everything's just binary from computer's perspective. All data are just numbers. So, images are interpreted as numbers, audio files are interpreted as numbers. Everything's binary from the computer's perspective. This is actually a text data. So I'll be highlighting the similar binary numbers here. Since this is a text data, what do you think would be those numbers highlighted in green? Just input it in the chat. Just want to know what are your guesses. Could be comma. Actually, some of you got it right. It's space. It's space. Yes. So it is the binary representation of this sentence. A robot may not injure a human being or, through inaction, allow a human being to come to harm. This is the first law from Isaac Asimov's 3 laws of robotics. So that's how computers understand all forms of data. But let's make it a notch higher. Instead of individual characters being turned into binary, let's turn each word into number. So here's an example. Let's just use the same sentence. We make a tabular representation of that sentence. So for every word, just count the frequencies. In this case, we see a 3 times in the sentence. So we put 3 here. Allow occurs just once, so 1. Being twice, so 2, so on and so forth. That's one way of representing text data. So I have a question. How about this example? What do you think is the answer?
Yeah, so most of our participants said the answer is...
Oh, okay, good.
Option
At least
A,
most of you got it
211.
right. Maybe some of them wasn't able to click the correct answer. Maybe through an accident. I don't know. But the correct answer is 211. So it's 211 because A has a frequency of 2 in this phrase, and then dime has 1, dozen has 1. So that's how you represent text data. This is so there, it's 211. This is actually called the bag of words representation. This is one of the traditional ways of representing text data. So in here, imagine using the whole English dictionary as your columns instead of just from those sentences. So you could end up having like thousands or even millions of columns. But that's the representation. That's the bag of words representation. And then in each of the row, it represents the individual sentences that you have. So the first row actually corresponds to the first law of robotics. The second row corresponds to the second law of robotics, and so on and so forth. So if you have like documents, large documents of data, you could do this representation. But the problem with that is some words mean the same thing, essentially. So being and beings, more or less, they're just the same thing. It's just a plural form of being. So what do you do with these kinds of texts? Well, one way of handling that is through stemming. Stemming just cuts off the suffix of the word. So, for example, others were turned into order, beings was turned into be, orders was turned into order. So with that, you could have a final table which has significantly lesser columns compared to before because you reduced it to its shortened form. But there's a problem with this. How about this example? Programmers programming programs. If you reduce it to its shortened form, it will become program. So it will end up being this program, program, program. Doesn't make sense, right? So one way of handling this is through lemmatization. So it's another way of reducing the word. Instead of just cutting the suffix, you convert it to its base form. So where is converted to be, cacti is converted to cactus, or is converted to be, and best friends is converted to best friend. There are actually so many techniques that you could apply, but these are the standard ones. It really depends on the data that you have. Sometimes you might have to use lemmatization, sometimes you have to use stemming, sometimes you have to use an entirely different technique. That's where the science comes into play. So this is very experimental when you're dealing with data. Another limitation of bag of words, of just that simple bag of words, is context. You're losing context because you're just you're removing the sequential nature of the data. So one way of handling context is by using this term called n-grams. So what it essentially is that you concatenate connected words. So for example, a robot will become one token, and then robot may will become one token, and then you continue that. So by doing this, you will get context. You could extend this by doing 3 grams or 4 grams. This is just an example. So in this case, we're just using 2 grams or called 5 grams. And I also want to let you know that there's also a technique that we use to de-emphasize certain words. So as you all know, there are words that really don't have that much value in a sentence, like the, or, and. What we do to give lower weights to these words are by doing the term frequency inverse document frequency technique, or we just call it TF-IDF. So what it does is, if certain set of words appear so many times in so many documents, then those words don't have that much value at all. So those words that are unique will have higher weights. That's the idea of TF-IDF technique. Alright, so there are lots of techniques, but I've covered some of the fundamental ones, and it's really up to you to study more on it, but it's a good foundation now. So because those things are, I would say, the often used techniques when dealing with text data. But those are just the pre-processing techniques. What are you going to do afterwards? How do you do the sentiment analysis or text remediation? That is where machine learning comes into play. So people mistake that NLP is a subfield of machine learning. Not necessarily. As I've mentioned earlier, NLP is just manipulation of text. Machine learning, on the other hand, is an entirely different thing. It just so happens that many of the techniques that we use in NLP are machine learning based. So I think it would be best for the non-technical people here to understand what machine learning is. So I'm going to be explaining machine learning in a nutshell. So what is machine learning? It is the ability of computers to learn without being explicitly programmed. Um, how we do it is by feeding the model with lots and lots and lots of examples, thousands or even millions of examples. For example, I have a picture of a cat, and I say, when the computer sees this picture, this is a cat. Then I have this dog, a picture of a dog. The computer will say, this is a dog. So feed it with lots of those examples until it will be able to determine that this input is this output. So what if we feed this model who only learned to categorize cat and dog with real pictures of those animals? What if I feed it with a silhouette of a cat instead? What will the model return? We don't know. Maybe a dog, maybe a cat. Machine learning is limited by the data that you feed it. So just have that in mind. Machine learning is just it's like a baby. You just train it with lots of examples. You spoon feed it until it learns. So that's what it essentially is. There are so in the context of NLP, this is how you do machine learning. So let's connect it with the bag of words representation we had earlier. For example, we have the following sentences, and then we tag the first two sentences as negative sentiments, and the last two ones as positive sentiments. That is how you train the machine learning. You feed. This is these are a few examples, but ideally you would need hundreds, thousands, or even millions of examples for the model to be able to generalize well. But that is the idea. Since you have converted the original text data into a format that is understandable by computers, you could now do machine learning techniques. There are actually two major types of machine learning. Supervised is the first one. In supervised machine learning, you identify input-output mapping, similar to what I have shown in the previous slide. And it has so many applications. You could build like this on the right side. You use detected web application where you input the news, and then it will spit out whether it is false, true, or whatever it is. So what I did to create this model is similar to what I have been explaining to you for quite a few minutes. So I did bag of words representation, I did all those pre-processing techniques, I fed it into an ML model, and then there. That is how you do machine learning on text data. Another type of machine learning is unsupervised machine learning. This is actually a trickier one because you don't have labels in unsupervised machine learning. So what you're doing here is you're trying to identify hidden patterns in the data without using the, this is what you should be. So when doing this, you would have to coordinate with domain experts to verify if what you're doing is correct. So on the right side, this is actually a team identification project that we have done 2 years ago. I did this with IAM. So we did text analysis of the tweets in Makati in July 2018. So we identified there are 4 main themes during that time. The first is food porn, second is current events, third is happy travels, and fourth is K-pop. So many people are into K-pop in the Philippines. Well, in Makati, to be specific. Another important thing in NLP is this. How do we capture the essence of a word? Because in the representations that we had earlier, we're just assigning a column to each word. But we know that there's much more into a word. If you hear king, you would imagine that king has to be male, it has to be rich. So there's so many things attached to the word king. But when we do the backwards representation, it uses all that information. So here's a very for example, king is the queen, as man is the woman. how do you um, how do you let the model understand these relationships? One way we could do that is by doing this. Let's assign coordinates for each word. So man will have 0, 0, king will have 0, 1, woman will have 1, 0, queen will have 1, 1. And let's just say, for example, that the first axis, when we have plotted this into a Cartesian plane, the first axis is femininity, the second axis is royalty. So we have plotted those words onto this plane, and then we treat them as vectors. By doing this, we could apply mathematical operations, and we will get very interesting results. So let's say, for example, we start with king, and then what if we remove the man characteristic of king, and then we add woman? What do you think will it end up? It would end up as queen. So if you go back to the previous slide, that's where the queen is. So that is how we represent words in and this is the techniques that we use currently. This is one of the recent advancements in NLP. This is actually called the word guidance representation. One popular implementation of this is the word2vec implementation by Google. So word2vec is actually a 300-dimensional vector representation of each word in the English language. So it was trained using the Google News dataset. They have like more than 1 billion words, and the model is 1.5 gigabytes. So this is a very important thing in NLP, because now we're not limited to just binning each word into just one column. Now we'll get more information than that. So in the examples I've shown, this is just 2 dimensions, but in reality there could be so many dimensions. As I mentioned, you will use 300 dimensions. So it's not limited to just femininity, or it could be so many things. And they have trained it using machine learning. So the machine learning put in the billions of words from Google News, and it identified the necessary values for the different dimensions of each word. I think this is a very complicated topic, and we don't have much time, but just so you know, the state-of-the-art NLP has been using this thing called attention mechanism, where you basically look at the whole sentence, and when doing machine translation, you pay attention to certain words or the others, depending on which part, on which word you are currently translating. And building up on that, there's transformers. This is the state-of-the-art architecture for NLP tasks. So just letting you know, so you could search it later if you want to. So this is what's being used in many of the advanced tasks in NLP, which we really can't cover because this is a very, very heavy topic. Another challenging task in NLP is text summarization. I'm just gonna show you an example because this is a very, very hard topic, but it uses the techniques that I've been telling you, like attention mechanism, transformers, in order to do this. This is a very hard thing to do. So this came from a project that I've been doing lately with IED. So this is the original paragraph, and then the AI model summarizes this into this. So that is one application of NLP. This is state of the art. There's so many topics that I really wanted to cover, but with the limited time we have, I think I can only spend so much time in the fundamentals and then breeze through with the advanced stuff. So that's it really. But I wanted to end it with this message. Artificial intelligence is not going to replace us humans, but it will augment us. Just my opinion, with the current techniques that we have in artificial intelligence, we're still very far from general artificial intelligence. And the general artificial intelligence is what you're thinking when you see Terminators or Transformers, those level of AI when they could reason for themselves. We're still far from that with techniques that we have. We have to come up with new techniques. Currently, what we're using are neural networks. That's the state of the art. But I think we have hit, we are plateauing now. We have hit the ceiling in terms of what neural networks can do. Those are just my opinion regarding AI. So. Anyway, Roy.
Okay, all right. Thank you so much, Jude, our resource speaker for natural language processing. Thank you so much for sharing with us your expertise and experience working in ADB on different NLP projects. Very insightful, very informative presentation. I believe you have a video to show us. But before that, I would like to encourage our participants this afternoon to please send us your questions in the group chat for consolidation. And then while you are watching the video, we will consolidate all your questions. And then let's see if Jude can answer maybe a few of them, since we just have a limited time frame for this particular event. So please send us your questions in the group chat. Thank you. So Jude, ready for the video?
Oh, sure. I'll be sharing a video of the project that I've been doing with ADB. This has the text summarization that I've been saying earlier. So this is one example of state-of-the-art NLP that you could see out there because there's not that much.
Jude, maybe you can share with us your computer audio as well. Jude, are you still there? Share with us your computer audio as well so we can have sounds while the video is playing.
Sorry, have I shared my audio?
I think
or
not
not
yet. Yeah.
Okay, I will be doing it now. I'm sorry for that. Let me do it again once more.
In a time of new development challenges and opportunities, knowledge is indisputably the new currency. Asian Development Bank, through its support to countries in Asia and the Pacific, spanning over 5 decades, has accumulated a wealth of knowledge, which is its real asset. And knowledge that comes from evaluations is a huge part of this asset. Independent evaluation provides evidence-based findings to learn from, and that helps better understand what worked, what needs to be improved, and why. This knowledge lends itself to better designed actions for improved development effectiveness and impact.
If you look at economic and social development, Asia and Pacific DMC is doing much better. So that also means their need is also moving toward the high end. That means beside financial support, you might also need knowledge, need capacity building, and policy advice. Then ADB as a family doctor for DMCs, we need prepared for the knowledge service. That's why I think it's very important for ADB to also move into a more knowledge bank.
However, despite a greater focus on knowledge and knowledge solutions, knowledge embedded in ADB operations is still not being optimally captured and shared for learning. ADB Strategy 2030 recognizes that while ADB can build on its strong existing knowledge base, it must also adapt to increasingly agile knowledge contexts driven by new and emerging technologies, such as artificial intelligence.
With artificial intelligence, this will help us so much with the way we gather data, we analyze data, and what that means is, for us, we will be able to make better informed decisions based on evidence. And what does that mean? in terms of project design, we will be able to actually design better projects. We have faster, quicker, and better access to evaluation data in which the lessons learned are actually included. So this will be very helpful for us for project design.
The Independent Evaluation Department, in partnership with the Information Technology Department, under its Digital Innovation Sandbox program, is piloting artificial technology to unlock lessons and tacit and experiential knowledge from ADB's pool of evaluation reports. Meet EVA, an artificial intelligence engine that analyzes self and independent evaluation documents to unlock learning and draw lessons embedded in evaluations. EVA scans thousands of evaluation documents in order to understand not just keywords, but context and intent. Through cognitive capabilities, EVA returns meaningful answers to complex questions. Not only that, EVA learns from the experience and improves itself, becoming smarter with each annotation.
Well, I think EVA is going to be a very valuable tool for all of us because it will continue to learn and continue to gather lessons. And so as people use it more and more and more, the answers will be very focused for whatever the question is that the person is trying to be sure they've understood. Whether it's when you're trying to summarize your findings for an evaluation or when you're trying to design a new program.
EVA identifies lessons from documents and groups them on a dashboard under their appropriate country, sector, theme, modality, and year. EVA also shows commonly appearing lessons and suggests related lessons which users can further explore. EVA, with its ability to reduce the amount of time and resources required to identify lessons, has the potential to aid and enhance usage of evidence-based findings across sector operations. This will lend itself to better designed actions for improved development effectiveness and deeper impact. Goals of ending poverty and boosting shared prosperity may become achievable with artificial intelligence. And with EVA, new gateways can be opened to reach better solutions.
Alright, Jude, I think that's the end of your video. Am I right? You're still on mute?
Yes,
yes,
that's the end of the video. That's the end of the video.
So our attendees for this afternoon actually sent us some very interesting questions about NLP, and maybe you can choose some of them in the interest of time. Maybe answer a few questions about natural language processing.
Okay, so there's this comment about stemming. That is true, actually. So what the audience said was that stemming relies on predefined set of rules and reducing the words to their basic forms, and so on and so forth. Yes, so when we do stemming, it ends up having the sentence have some. So the sentence that end up as output when doing stemming will have words that are not really part of the English language, but you get the idea. So, but yes, I agree with what you're saying. There's that limitation when doing stemming. There's also this comment about gender and social class bias, depending on how the program designs the training model. Yes, that is true. That's a very serious topic actually in the field of artificial intelligence. And researchers are thinking of ways on how to reduce the bias. I actually want to discuss some of those technical approaches, but I think this is not the right crowd to explain those technical stuff, but there are techniques in order to reduce the bias. But I can't say that it is perfect, but at least they have attempted to reduce the bias in certain words. It actually uses the same technique that the same concept as word embedding. So remember that there are vectors for different words. So at a high level, what the researchers do is that they remove they they subtract the vectors of those words that are pertaining to gender to the different representations that they have in order to reduce the bias, because there are examples out there when you could see that just for example, I'm thinking out of the blue. So if you see a doctor, then he should be male, something like that.
Jude, I've muted all the participants. I think there's noise in our background. If you can just unmute yourself again. Thank you.
Sorry. Okay, where was I again? So AI suffers from those limitations, from limitations pertaining to gender bias, and what they essentially do is they subtract vector of different words pertaining to gender to their representations that they have in whatever the document. So sorry, it's a very technical thing. Maybe we could chat about that, but I think it's something that I should not speak about during this session, because there are many audience here that are the general public, so they can't understand the technology. So sorry, let's just talk about it later. There's also this question about sharing practical usage of NLP ML other than the examples that I have shown. I think a good practical example of NLP right now is by analyzing text data about COVID, anything pertaining to that. So I remember seeing this article on Medium by some data scientist here in the country, where he did thematic analysis of tweets pertaining to COVID. That's something that you could do. It's quite easy, so you could do that. Actually, it's the same thing as what I've done with the analysis of tweets in Makati in July 2018. Same stuff, but instead of tweets in Makati in July 2018, just replace it with tweets about COVID. So another question there is are there word embeddings and language models for the Filipino language? As far as I know, there's none, but there's probably one group working on it. It's Senti AI, because they really focus on NLP tasks. They have been trying to create NLP models for local dialects, so maybe you could ask them, but I'm not entirely sure if they have word embeddings. What I remember is they're using rule-based approach. So, what are the best resources to learn NLP? Well, in general, I study the fundamentals of everything. So, I read books, I take online courses, and then build from there. So once I've done that, I create projects, and then read random blogs on the internet. So I'm just aggregating lots of information from different sources. That's what I do. But mostly you have to implement it. You won't really learn if you don't implement it. You won't learn by just reading. There's also this question, I think this is coming from a software engineer, because the question is, what NLP paths do you usually use to integrate with applications? Generally, I build all the models on my own, unless there are pre-trained ones. But regarding the question about is there a platform that I use? If it is a chatbot, then there are lots of platforms that you could use for them. But for other NLP tasks like theme identification, text integration, all those things, there are no such platforms yet. You really have to do the coding on your own. So for most tasks that I do using NLP, I don't use existing platforms. You usually code them by yourself. What is the most, so sorry, another question in the chat is, what's the most difficult NLP problem I have encountered? The hardest was actually this EVA one, this text summarization generation, because this is state of the art. It's really at the edge of AI. So I've told you we're far from general artificial intelligence. And just last year, if you look at the news about AI, all of them are about NLP, BERT, doing this text generation thing. This is really the state of the art in AI. What I've been showing you, this really state of the art. This is harder than semantic segmentation problems in computer vision or other things. So yes, this is the hardest. Are there any NLP projects that are capable of handling mixed language text like Taglish messages? I don't have an experience on this one, but I think there is, because if you look at Facebook, they are capable of translating Taglish messages into English. So there should be one, but I haven't done it myself, so I'm not really sure. Is it, so another question here, there's a question about sarcastic remarks. Were you able to consider these in sentiment analysis models? Just my opinion on sarcasm. Even us humans are having a hard time figuring out sarcasm, so what more of computers? It's harder for them to detect sarcasm. Even us can do those things. And it usually depends on whether you know the person who's speaking, who's conveying that message. So for example, I'm trying not to think of political stories, but let's say I know Roy very well, and he made a statement that is very against his views. So I know that's sarcasm because I know him. But so what I'm trying to say here is, you only detect sarcasm because you know the person, you know what he has said a few times before. But he's deviating from what he's saying ago to what he's saying now. So that's how you know that it's sarcasm. But if you just put it as just text, you won't know if it's sarcasm. What's another question here? Is it possible to use some of the NLP techniques on pictographic
Maybe
language?
Jude, maybe just one last question before we end our seminar for this afternoon. One more question.
Okay. Is it possible to use some of the NLP techniques on pictographic language like Mandarin? I haven't done so myself, but I think it is possible. You just represent each character into a format that's understandable with the computer, similar to what I've done with the bag of words representation, but instead of English words, just use Mandarin. So same stuff.
Okay, so much as we want to entertain more questions, we're running out of time. We just have 1 hour. Maybe next time we can
all right.
set longer sessions. Thank you so much, Jude. Questions are still pouring in, but if you have further questions, maybe you can direct your questions to Jude. I think he displayed his email address earlier. By the way, we are joined by Miss Anika De Leon from the AAM Career Services Office. We have recently established partnership with AAM CSO. Thank you so much for being so supportive. Looking forward to collaborating on more projects with the AAM CSO soon. I think, Jude, meron ka ding you have fans here. Jude's #1 fan. I think that's Janlo from the MSDS 2020. Hi, Janlo. Hi, people from MSDS 2019, 2020, and then 2021. Hi. Thank you so much.
Yeah, I have GitHub.
By the way, if you are interested for similar opportunities in the future, please like us on Facebook, AIM Society of Innovators. That's the link. And if you have specific questions or if you are interested to be one of our future speakers, please drop us an email at rroberto@aam.edu. So that's me, Roy Joseph R. Roberto. So again, thank you so much for your time. Unfortunately, we don't have much time to go on with the Q&A portion, but Jude, thank you so much for that wonderful presentation. You really are a rock star, and I hope you can continue your career in improving our regional development, since you're working with ADB, using data science and artificial intelligence. Thank you so much, and yeah, let's keep in touch. Bye-bye.
I'm gonna go back to the next slide. Roy.
Yes?
Do we wait?
Pwede naman. No, maybe just a casual talk. Since ano. By the way, no, we are also participated, we are also joined by people from other countries. Like, I saw participants from Cambodia and Thailand. So it's technically this is an international seminar or conference as well. And then maybe we can organize in the future the very important note by one of our attendees, how to remove bias from NLP systems. Maybe we can schedule a special session for that.
We can attempt, but just my thoughts. It's a really hard problem in AI. It's really hard. Not much people have been doing that. Especially in the models that we have right now, where we have millions of parameters. It's hard to keep track of all the features that you have. So that's one limitation of state-of-the-art architectures or techniques in artificial intelligence. You're sacrificing interpretability with accuracy.
I'm seeing a lot of familiar names in our attendees. There's Jonel Contreras from MSIB. I hope we can invite him in the future for a digital seminar here as well. Yeah. We also have Peeps from MSIB 2021. We have Ramon Navarro. Yes. Actually, Jude, we are attended by nearly 140 people for this particular session. So I think that's a really good number based on our past events. So yeah, I hope our participants can follow us on Facebook for future announcements.
Yeah, sure. More discussions would be great.
Anyway, Jude, if you have nothing, I mean, if you have other things to do, you can actually leave the meeting na. But thank you so much for your time. Maybe offline na lang tayo mag-usap ulit.
Yeah.
You're welcome, Hisco Apeles from MSDS 2021. I heard, buong batch nila halos umattend for this particular session. So thank you to Jason Dalorso for encouraging your classmates to attend this session as well. There you go. Ayan. Oh, sige na. Maybe, it's time to go na. I'll end the meeting na. Again, thank you so much, guys.
Thank you so much, guys. Goodbye.
Looking forward. Bye-bye. Bye-bye.
Hey, Camille. Si Camille.
Si Camille?
Camille.
Camille.
May shout out.
Shout.
Beno is also here. Friend from college. Hi, Beno. He's also here. I don't know. Yun lang. Naman is here. Hi, Pat. Pat and Naman. Hi, Toti. Hi, Sempron.
By the way, Jude, I think you're currently organizing a hackathon in ADB, di ba?
I'm part of the organizing committee. So I can act as mentor.
Dapat pala kanina, inano natin.
Yeah, Pub, guys, we have an ADB AIM hackathon. So if you guys wanted to join, please do. So it's about COVID. There are 4 categories: health, education, wellness, that other one. But I have shared the details on my Facebook account. you want to join, please register. And you could get up to 50,000 US dollars in funding if you get as the winner for any category.
You said US dollars, right? Not
Yes,
pesos.
50K, so it's
Wow.
2.5 million.
That's big.
Yeah, you'll be getting 2.5 million pesos.
Oh, by the way, we're officially done. It's adjourned na, so the attendees can, I don't know,
Shoot, joke.
joke na. We're just having an informal talk, like sort of debriefing. Do you still have something to share? Because I'm gonna end the meeting now.
Well,
Okay.
if you have questions, just
Wala na.
chat me.
Okay, right. Thank you again.
Thank you guys.
Goodbye.